Fine. Before I start explaining the Redox chapter, I think there was a question from probably from Kavish, I think,
Yes, sir.
right? Regarding uh, d orbital, I think it was x square minus y square probably, and the question was that what is the electron density along the xy plane, and the answer is obviously zero, which I answered, but I said I will explain it why it is zero in the class. Here different types of d orbitals, 5d orbitals are shown. So the xy means it is in xy plane, but no lobe is along the axis, xy axis. Okay, so you can see no lobe is along xy axis, although it is in xy plane, right? Similarly, for YZ, it will be YZ plane, but they will not be along Y and Z axis. Similarly, Z and X, DZX, it will be in ZX plane, but it will not be along the Z and X axis. So you can see here YZ also DYZ. It is in YZ plane, but not along the axis. Okay, and so on. But if you see the dx square minus y square, okay, and this is the dx square minus y square, and see just this point, okay, from here to here. Now if you see the xy plane, it is along the xy plane and also along the axis. Okay, so I'm just going back. It is in xy plane, dx square minus y square, and also along the axis. And if you see the plane itself, and this plane is actually just uh, doesn't have any width, it is of zero width. So this plane, if you see this plane has zero width. So 50% is on the right hand side, 50% on the left hand side, but no electron density on the plane itself. Plane is just vertical to your screen at the moment. So that's why the electron density is zero in the plane. 50% right, 50% left, zero in the plane itself. Is that clear, Kavish? Why it is zero?
Yes, sir.
Right? And this is really a good question. Has appeared in JEE, right? This question is from JEE previous years. And if we continue, right, for example, dz square, that is also again in along the z-axis. Dz square is along the z-axis, and again in the plane the density is zero, because on a plane density will not be there. Either it will be on the left hand side or right hand side in all cases. Okay.
Sir, I have a doubt.
Yes.
What does this circle represent?
Well, circle is again the region where electron will be found. So this is the solution of Schrodinger wave equation, what we have talked about. So circle also indicates the region where we will find the electrons in dz square orbital. Okay.
Okay, sir.
So it is the region where electron density will be there of the electrons of dz square.
So
Yes.
in the dz square, will the electron density along x and y axis be zero?
Along the axis, it is along the axis. If you
Just
see
along the xy plane.
Yes, if you see along the xy plane doesn't have any width, right? So if you see the plane, the density will almost be zero, and the reason is very clear, because plane doesn't have any width.
Answer along axis.
Along the axis, again, when we say axis, then it is said in that direction.
Yes,
Okay,
sir.
so there is slight difference between axis and plane. When we say axis, it is said that in right direction, in left direction. So for example, if I say x-axis, so x-axis might be in the right direction itself. So in that case, it might not be zero, because the convention is different in understanding. Are you getting me what I am saying?
Yes, sir. So like, can we find in this case?
Uh, Not 5, it can be 0.5, you can say, or 50%.
Oh, okay.
Now moving to the next point, which is the types of reactions we were talking about. Okay, so the types of reactions here, uh, we have already talked about two types of reactions, the combination reaction and decomposition reaction, and also you remember the uh, condition also. Okay, condition that why these are called redox reactions and why these are called combination and decomposition reaction. Before I move forward, just raise your hand who will tell me that what is the condition which makes a combination reaction a redox reaction. Not all the combination reactions can be redox reactions. What is the necessary condition which you can be sure that yes, it will be a redox reaction then? Okay, Divyansh, Yash Bedi, Samad Pratham, and let me see, Ishwar, Kartike, Arna, sorry, Amir. Raised hand. I will give chance to Ishwar. Yes, Ishwar.
So at least one of the reactants should be in elemental form.
Right. That is the condition, that one of the, at least one of the reactants must be in free elemental form. Good. And same is true for the decomposition also, but that will be for products, because in that case, we will have one reactant, products, at least one product should be in elemental form. Good. That is the something definition of oxidation, okay, and reduction, Samad. Okay, for combination and decomposition, the condition is different, slightly different. Okay, and then we
Okay.
talked about few examples also here. Now, this one is not a redox reaction, and the reason is very simple, because in the products we don't have at least one, anyone in the free elemental form, and that's the problem. That's why it might be a decomposition reaction, but not a decomposition redox reaction, because both of the compounds are in compound form, not elemental form. So not a redox decomposition reaction. Next one is displacement reaction, and it is very simple, similar one we have already done basically. The only thing is we will be talking about two types of displacement reactions. One is metal displacement and the other one is non-metal displacement. And as the name says, that is the point there, that metal is displaced or non-metal is displaced there. So displacement reaction, you already know from your previous grades that, for example, I'm not talking about in reference of redox. For example, in electrochemistry type of reaction, you know that zinc replaces copper from copper solution and produces zinc sulfate. Okay, so this is a type of displacement reaction where metal displaced a metal. So metal displacement, non-metal displacement, metal displacement where metal is displaced, non-metal where non-metal is displaced. These reactions are important, examples are important. All the reactions, wherever you see the reactions, make sure that you write and memorize right from now. Make it a habit. If you don't do that, you are going to struggle afterwards. You are going to say that chemistry is very tough, chemistry is very boring. Right from now, whenever you see any reaction, memorize it. Okay, so here also, from chromic oxide, chromium is replaced by aluminium. So aluminium replaces chromium, so chromium goes out. Now, in each case, the reducing metal is a better reducing agent. And this is the reactivity series which you have been studying from your 8th grade, that the metal which is more reactive displaces the less reactive metal. Zinc is more reactive than copper. So you know that zinc is more reactive than iron, is more reactive than copper, etc. We will be talking about a series and you have to memorize almost all those elements. Okay, so it means zinc will displace iron, iron will displace copper, etc. Non-metal displacement. Redox reaction include hydrogen displacement and rarely occurring reaction involving oxygen displacement. So normally hydrogen displacement will be there in redox displacement reaction, okay, non-metal displacement reactions, but sometimes oxygen displacement will also be there. This is very common one where sodium has displaced hydrogen from H2O. So displacement reaction, and it is metal has displaced non-metal, non-metal displacement reaction. Calcium displaces hydrogen, magnesium displaces hydrogen, iron displaces hydrogen. In all such cases, you can see that because we have water here, okay, so it might be in the form of oxide, but with water it is in the form of hydroxide. H2O in all three, first three you see, it is actually in the form of hydroxide. Okay. In the last one, hydroxide is less stable than oxide, so that's why it is in oxide. So it is actually how soluble it is. So depending on the solubility, product might differ, but in all such cases it is actually the oxide. This is in these three, oxides in water convert to hydroxides. In the fourth one, oxide doesn't get converted because it is not that much soluble. Many metals, including those which do not react with cold water, are capable of displacing hydrogen from acids. So zinc displaces hydrogen from acid, magnesium displaces hydrogen from acid. All these reactions write and memorize. Normally students do not have clue how to answer the question if they don't remember these reactions. The only requirement is that if you remember the reaction and related chemistry related to that, whether it is reduction, whether oxidation, whether hydrogen displacement, whether metal displacement, you will be able to answer most of the questions. Then this one is disproportionation reaction, and amongst all the types of reaction, redox reactions, this is the most important in the sense that most of the questions from reactions will be from here. Types of reactions, okay, the types of reactions will be from here. And what is disproportionation reaction? It is a very simple thing to understand, that the same element in a compound gets oxidized as well as reduced. So the same element, so in the reactant, we have one element, and in one compound, it gets oxidized. Okay. And it produces another compound. So I'm keeping plus in between intentionally. Here it is reduced. It means there must be at least two compounds. There should be basically two compounds in the product side which should have the same element. So probably sometimes you will have phosphorus here, okay, or nitrogen here, and you will get two compounds which will have phosphorus here. In one case, the oxidation state of phosphorus will increase. In another case, it will decrease. The case in which it will increase, oxidation; in which it will decrease, reduction. So definitions will be same, but reaction is slightly different. So if you see here, you have oxygen in both the products and also in the reactant. In one case, the oxidation state of O2, in peroxides, oxidation state of oxygen is -1. We talked about it in previous class. In one case,
Yes, sir.
it is reduced to -2, decreased to -2 means reduced, reduction. In another case, -1 to 0 is actually increase, so it is oxidation. Same element in a compound got oxidized as well as reduced. That's why it is disproportionation reaction. Similarly, P4 in its elemental form, any element has zero oxidation state, so that's why 0 here. From 0 to -3 it is reduction. From 0 to +1 it is oxidation, increased. Chlorine 0 to +1 oxidation, 0 to -1 reduction. So definition is very simple. Examples are very simple. You need to just memorize these examples. Okay. A few examples are of nitrogen also. We will be talking about later on.
Sir, can you please once again show the definition? I was disconnected due to some network issues.
Okay. The definition is very simple. The same element in a compound gets oxidized as well as reduced at the same time.
So what is the meaning of the sentence at least 3 oxidation states?
I'm coming to that. Okay. Now to happen to for disposition reaction to take place, what is the necessary condition? Necessary condition is that if I have a value x, say I have a compound here and I have an element A here and it has oxidation state x, and I say that in another compound A will be there and in another compound A will be there, two compounds will be produced where A will be there, and in one case oxidation state of A is increased, oxidation takes place, and in another case oxidation state of A should decrease where reduction will take place. It means oxidation state of this one should be less than x, sorry, greater than x, this one, because here oxidation is taking place, oxidation state increases, say x plus 1. It can't be x, it will be greater than x. And in the other case where reduction is taking place, oxidation state decreases. It means its oxidation state should be less than x, say x minus 1. It means this element A must have at least 3 oxidation states. One x, the other one less than that, and the other one greater than that. Otherwise, disproportionation reaction will not take place if the element has only 2 or 1 oxidation states. Is that clear? What
Yes.
I am
Yes,
saying?
sir.
Yes, sir.
So can you repeat again, please?
At least 3 oxidation states should be there so that it can go higher and lower both. Among halogens, fluorine does not show a disproportionation tendency because it can have only 0 and -1 oxidation state. In its elemental form, 0, and in all its compounds, it has oxidation state -1, no exceptions. So it means fluorine will never show disproportionation reaction. So if you get a question related to that, you can be sure that you can strike off fluorine. If disproportionation reactions are asked, that reaction you will not consider. So sometimes the question comes that which one is not the disproportionation reaction or which one is the disproportionation reaction. So there it helps to consider these type of
Excuse me, sir.
conditions. Yes,
Sir, can you please show the reactions?
yes.
So these reactions will be in the chapter notes, right?
Reactions are there in chapter notes, but try to memorize all these reactions when you see. As I said, okay, whenever you see these reactions, try to memorize. Even if you see on internet, try to memorize at that time. Don't waste that time. It will take just 20 seconds, 15 to 20 seconds. So these are there, but make it a habit. The moment you see reaction, try to memorize. Now the question related to the concepts we have done. Which of the following species do not show disproportionation reaction and why? And you know the condition. We have talked about the condition for disproportionation reaction. So just try to find the answer before I explain.
Sir, maybe they don't have 3 oxidation states.
Yes, indeed. That is the concept you have to apply. That is 100% sure you have to apply that concept. So you need to first calculate the oxidation state of chlorine. These are oxides, so oxygen will have -2 oxidation state. Chlorine will have different oxidation states here. So if you calculate the oxidation states, ClO minus, it has minus charge, it means sum of all oxidation states will be -1. So ClO will be X is oxidation state of chlorine, plus -2 is oxidation state of this oxygen, equals to -1. So X equals to 2 minus 1, that is +1. So here oxidation state of chlorine is +1. Oxidation state of chlorine here will be X plus 2 times -2 equals to -1. X equals to 4 minus 1, that is +3. Okay. Oxidation state of chlorine here will be X of chlorine plus 3 oxygens, 3 times -2. Total charge is -1. That is X equals to 3 to the 6 minus 1 plus 5. Oxidation state of chlorine here will be X plus 4 times -2 equals to -1. X equals to 8 minus 1, that is +7. Now, the oxidation state, maximum oxidation state of chlorine possible is +7. It cannot go beyond +7. There are 2 elements only in periodic table I will be talking about later, which can have 8 oxidation state, and that is as an exception. Okay. So +7 is the maximum oxidation state. Chlorine cannot have beyond that. But chlorine can have less than +1, because if it is in elemental form, it can have 0. So less than +1 is possible. So this chlorine can get reduced as well as oxidized. Similarly, this chlorine can get reduced from +3 to +1 and can get oxidized. Oxidation state increases from +3 to +5. Similarly, this one also can get reduced and oxidized. But ClO4 minus can get reduced only, cannot get oxidized. So it means ClO4 minus cannot show disproportionation reaction. If I have ClO4 minus here, I cannot have 2 compounds here in which in one case it can show less than +7, or in one case greater than 7. Is that clear what I am saying? Or if any confusion, let me know. Very common question which appears in your exam.
Could you please explain again,
You
sir?
can explain again.
Okay. What is the condition for a redox reaction to be disproportionation reaction? The condition is that that element should have at least 3 oxidation state, one greater than and one less than, one in the middle, the other one. So this one will always the middle one, the reactant. When oxidation is taking place, here it will be greater than that. Where reduction is taking place, here it will be smaller than that. Okay, so that's what I explained, that here oxidation state is X, here will be X plus 1, or here will be X minus 1 in case of reduction. But if oxidation state of the reactant ClO4 minus is +7, so it can go to less oxidation state, +5, +3. So this one is possible. It can show +5 if it is converted to ClO3 minus. Okay, so here it will be +5, but it cannot show greater than 7. So this part is not possible. It cannot get oxidized. It can only be reduced. It cannot get oxidized because the oxidation state of chlorine greater than 7 is not possible. Is that clear now? Why it doesn't show the disproportionation reaction? Clear or not what I am saying as per definition?
Yes,
Or if
sir.
there is still any confusion,
sir.
ask that point only. Ask that point which is not clear so that I can elaborate on that. If any part is not clear, it should get oxidized, it should get reduced as well. But ClO4 can get reduced only because it is already in highest oxidation state of chlorine. So chlorine's oxidation state cannot go beyond +7. So it cannot go to +8. So it cannot get oxidized. The next question. Suggest a scheme of classification of the following redox reaction. Means which type of reactions are these? So whenever you are asked about what is the scheme of the classification, means classify as combination reaction, disproportionation reaction, decomposition reaction, etc. Okay. So raise your hand if you want to tell me the answer of the first one. Only 2 hands raised. Okay, Yash Bedi, yes, tell me the answer.
It is a combination reaction as well as a redox reaction.
Okay, yes. Samad, why it is a combination reaction?
Sir, because only a single product is being formed with the help of two reactants, that is nitrogen and oxygen.
Karthike, same question passed to you. Why this is a combination redox reaction?
It is a combination reaction because a single product is formed as because of two reactant, and it is a redox because both of them are in elemental form, or we can say at least one is in elemental form.
Right. So that has to be mentioned. If it is asked that why do you think that A is the redox reaction, or in this case combination redox reaction, you will mention both conditions. The first one is that only one product is being formed, and the second one, to prove it is redox reaction, that the at least one reactant is in elemental form. Okay, now the second one, 2PbNO3 whole twice 2PbO2NO2. Who will tell me the answer? Okay, many hands raised. I will give chance to, okay, Pratham, yes, tell me the answer.
Sir, it is decomposition redox reaction, sir, because uh, at least one in this the product is in elemental form in case of O2, and sir, both oxidation and reduction is occurring in this reaction.
Right, good. It is a decomposition redox reaction, and the reason is very simple, because we have only one reactant here, and in the products, one element is in elemental form. Now see who is going to give me the answer. C part. Raise your hands, and if your hand is raised from the previous question and you don't know the answer of this one, make sure that you lower the hand. Okay. Yes, Arjun, tell me the answer. Third one.
Sir, it is a displacement redox reaction.
Why? Tell me the reason.
Sir, I'm not able to recall it.
Okay. I pass it on to Karthike. Yes, Karthike. Which type of reaction it is and the reason.
So it is a displacement redox reaction, and it is a displacement redox as hydrogen of water has been displaced by sodium.
By
And
sodium. Okay. Okay. Right. So one more thing, I think. Fine. Okay. Who is going to answer the fourth one? See, I'll explain again, okay? Because there a few students will remain confused, okay? D, who is going to explain the answer for D? NO2 plus OH minus gives you NO2 minus, NO3 minus plus H2. Anyone? Okay, Yash Bedi.
I think it is a disproportionate reaction.
It is? Come again?
Proportionate reaction.
Your voice is not clear. I think
A disproportionate reaction.
just a second, let me. Now tell me yes.
disproportionate reaction.
Okay, right. Explain how.
Whereas nitrogen is getting reduced and oxidized at the same time.
Okay, right. Good, good answer. Okay. Now the C part, if you see in reaction
Sir, I
C,
had a doubt.
you have a doubt. Okay, just a second. Hydrogen of water has been displaced by hydride ion into hydrogen gas. So remember in the previous examples where we talked about the displacement reaction, it was sodium. Okay, sodium, calcium, magnesium, iron, metal displaced. But here's from the hydride, this one. So what's happening here? Hydrogen of water has been displaced by hydride ion into the hydrogen gas. Okay. So it is ionic reaction basically. That's why it is sort of, we are saying that hydrogen has displaced, because NaOH actually remains in the water, because this remains as a solution, Na plus and OH minus. So this actually oxygen is here with hydrogen. So slightly different, but you will consider it as displacement reaction. Okay, so now what was the confusion, doubt? Tell me.
Sir, in disproportionate reaction, does any one of them have to be in elemental?
No, not necessarily. In disproportionation reaction, that's not a necessary condition. That is a necessary condition for combination and decomposition reaction, not for disproportionation reaction.
Okay, sir.
For disproportionation, the necessary condition is that the element must be in 3 oxidation state. Now, very good concept, fractional oxidation state. Many a times we will be talking about fractional oxidation state, and there are different reasons for elements showing fractional oxidation state. In most of the cases, it is not the fraction, rather it is average of different oxidation states of the same element if it is present in more than one atom form. So for example, if we have 3 oxygens in one compound, and out of those 3 oxygens, 2 have one oxidation state, the third one has different oxidation state. So in that case, the oxidation state average will be fraction. So in most of the cases, it is not actually the fractional oxidation state of the element, but the average is fraction. But in few cases, exceptions are there, and those exceptions are that O2 minus and O2 plus. So these you can remember as exceptions. In these cases, oxygen actually has fractional oxidation state. Okay, minus half and plus half, but otherwise, in almost all the cases, it will be average, which is fraction. And within average also, there might be 2 different reasons I am going to talk about. So I have already told you. Now the oxidation number of carbon, these are the examples. Okay. So this is called carbon suboxide. Why this is called carbon suboxide? Because normally carbon, if oxygen is associated with carbon, then it is CO2. So the ratio is 1:2 or at least 1:1. But here oxygen is less than carbon. Okay. 1:1 would have been 3:3, right? But oxygen is less. So that's why suboxide. It has oxidation state 4/3, which is fraction. Oxidation number of bromine in Br3O8 is 16/3. Again, Okay. Here sodium thiosulfate again 2.5, which is fraction. Why this is so, we will be talking about now. So if we see the structure of carbon suboxide, C3O, this is the actual structure, and you have to memorize the structure in all such cases, okay, where it is dependent on the structure. So you can see there are 3 carbons, but 2 carbons have oxidation state +2 and 0, the other one. And this is something related to in the previous class what I told you, that how the charges are balanced. So if you see symmetrical structure, draw a vertical line. I hope you remember that I said draw the vertical line if it is symmetrical. And then see on the left hand side and on the right hand side how the charges are balanced. So this -2 charge, oxygen is not in superoxide mode, oxygen is not in peroxide, oxygen is not with fluorine. So it means oxygen is in its normal oxide form. So oxygen will have -2 charge, -2 oxidation state. To balance this -2, this carbon will have +2. To balance this -2, this carbon will have +2. And this is how the charges are balanced. Suppose instead of one oxygen, there would have been many. So all these oxygen oxidation states will be added, and those will be balanced by this one. So we will see that example also. So here we have only one oxygen. So whatever charge is there, that will be balanced by carbon. So if these have been balanced, the middle one will have 0. So that's how charges are balanced. The middle carbon does not need to transfer its electrons on either side. It can't, because it is symmetrical on both the sides. So it can't transfer the electron on either side. The overall oxidation state will be average of the 3 oxidation states, that is +2, +0, +2 divided by 3. So the oxidation number of carbon in this case will be sum of oxidation states divided by number of oxidation states. So it will be +4/3, which is a fraction, but actually it is average. Now the element marked with asterisk, there was carbon marked with asterisk. In each species is exhibiting the different oxidation state than the other one. So here in this case, other carbons, these were showing +2, but this one was showing different. So that's why this is marked as asterisk. So this is the convention to show the carbon or the element, whatever element it is, which shows different oxidation state as compared to others. Now the structure of tribromo octoxide Pr3O8. This is the structure. And as I said in the previous case, the line of symmetry is this one. Okay. On the left hand side, you will balance the charges. On the right hand side, you will balance the charges. Rest the charges will be balanced by Br. Okay. So because you have here -2, -2, -2, -6 will be balanced by +6. So bromine, left bromine will have +6 charge, hence its oxidation state will be +6. Similarly, on the right hand side, -2, -2, -2, all -6 will be balanced by one bromine, this one, so +6. But in the middle, this bromine is also attached with the 2 other oxygens. So it has to balance, this bromine has to balance these 2 oxygens. So these 2 oxygens will have -2, -2, that is +4. That will be balanced by the bromine to which these are connected. Is the concept clear how to get the oxidation, individual oxidation states in a molecule? Okay. Any confusion you need to ask?
Sir, can you repeat again?
Okay, what I am saying that in all such cases where you see symmetry, you need to first draw the line of symmetry, vertical line of symmetry, not horizontal line of symmetry. Okay. And then balance the charges on left hand side and right hand side. On left hand side, you made the charges 0, -6 + 6, 0. Here -6 + 6, 0. So from here you got the oxidation state of bromine, on left hand side and oxidation state of bromine on right hand side. Is this clear up to here?
Yes, sir.
Okay, but in the middle, so this is 0 now. Okay, in the middle it has to have 0 charge. So if it has to have 0 charge, we know that oxygen has -2, -2. These -4, -2 plus -2 have to be balanced to make it a 0 overall. So it means bromine will have, central bromine will have +4 oxidation charge, so that this becomes 0. Now overall molecule doesn't have any charge. That's why we have to have 0 charge overall. Is that clear?
So means according to oxygen, we will find the oxidation charge of bromine.
Yes, correct. Correct. In few cases, if oxygen is in peroxide state, so if it would have been in peroxide state, it would have been, the bond would have been like this. So this is peroxide linkage, but there is no bond like this. We have double bond O. There is no CO2 like that. So it is not in oxidation state other than -2. So all it is normal oxide -2. Now we see that oxidation states of bromine are +6, +4, +6. We will have this bromine as asterisk because this one shows different than other one. So oxidation number of bromine in Br3O8 will be their average. So sum of oxidation states divided by how many? These are 3 plus 16 by 3. It does not mean that bromine has oxidation state plus 16 by 3. It is the average only.
So,
Yes.
in carbon suboxide, sir, how is the oxidation state of carbon +2?
As I said that you have to draw the line of symmetry. Now left hand side, right hand side, same. And then oxygen is not superoxide here. Oxygen is not not superoxide here, not peroxide here, not attached with fluorine. It means oxygen will have oxidation state -2. Okay, oxygen has different oxidation states only if it is attached with fluorine, or it is peroxide, or it is superoxide. Okay, so to balance this -2, this carbon must have +2. So here you balance the charges 0. Similarly, on the right hand side, you balance the charges. Now the charge is 0. Because right hand side, left hand side 0, and there is nothing attached to carbon now, it means carbon will have 0 oxidation state. It does not need to balance anything now. There is nothing remaining, no charge remaining to balance. Is that clear?
Yes, about it.
Now sodium tetrathionate or simply thionate ion, if you remove these sodiums, you will call it tetrathionate ion, or in this form you will call it sodium tetrathionate. Again the same concept. Okay, the same concept, how to balance the charges. First draw the line of symmetry. Okay, and what we are going to do, we are going to see that why sodium tetrathionate, in sodium tetrathionate sulfur shows the oxidation state as 2.5. Okay, now see, if you draw the line of symmetry, the left hand side and right hand side are same. Okay, sodium will always show oxidation state +1. You know that. Okay, the rule of oxidation number, alkali metals always +1, alkaline earth metals always +2. So to balance this +1, this oxygen will show oxidation state as -1. So it is similar to what you have actually OH minus, for example, sometimes. So here O, if you remove H, so here also it has O minus. More about it in subsequent lectures. But here understand that to balance this +1, this oxygen will have -1 charge. So here it became 0. Similar concept as we are applying till now. Now this sulfur balances this -2, this -2. These oxygens are in normal oxidation states because these are not attached to anything. These are not superoxides. These are not peroxides. Okay. So either it can have different oxidation state if it is attached to an element which has a specific oxidation state. For example, sodium cannot change its oxidation state. Always +1. So oxygen will have to change its oxidation state. That's why -1. But if you consider the other two oxygens, these are not connected to any other element, and these are not superoxides, these are not peroxides, these are not attached to fluorine. It means -2 oxidation state. So it means this sulfur has to balance how many oxidation states, how many charges it is balancing. It is balancing -2, -1, -2. Okay. So it means it has to balance -5 charges. Its oxidation state will be +1. That is how you do. To understand it in a better way, Na, if you consider it as ionized, Na plus will be here, Na plus will be here. And similar to if NaCl gets ionized, you get Na plus Cl minus. Okay. So Na plus will be there, and the other part, oxygen, will gain negative charge. So I have just broken, to understand it in better way. If I break these, this will be the condition Na plus O minus. So if this is minus charge, this is -2 charge, this is -2 charge, total -5 will be balanced by +5. Similarly here on the right hand side of the symmetry, -1, -2, -2, -5 charge will be balanced by +5 by the sulfur. Okay. In the middle, these sulfurs do not need to balance anything because this neutral balanced everything 0. This is also 0. And if you have just sulfur connected to each other, they will not transfer electrons to each other because these are symmetrical. So in the middle, you have just symmetry. So if you have symmetry, no transfer of electrons from sulfur to sulfur will take place. The other things have already been neutralized, means charges have been neutralized. So if I see here, the oxidation states of sulfur in sodium tetrathionate or thionate ions are +5, 0, 0, +5.
Sir, 5/2.
Not okay, 5/2. Yes, correct. Okay, so the average oxidation state will be sum 5 plus 0 plus 0 plus 5 divided by how many these are? These are 4. Means 5 plus 5, 10 by 4, that is 5/2, that is 2.5. And that's what we had to show, that why it shows 2.5 oxidation state, sulfur. Any question here? Let me know.
Sir, I had a doubt.
Yes. What is the doubt?
Sir, Na has oxidation state +1, and to neutralize it, the oxygen has oxidation state -1. So sir, in the first image, the first sulfur, sir, why there is a need that the sulfur is balancing the oxygen left to it, having oxidation state -1.
Okay, the reason is because this compound exists in ionic form. So you actually have this as one ion and Na plus is detached from it. That is the reason. That's why, the word ion has been written specifically. Because this sodium cannot balance or cannot neutralize this oxygen because it is not attached to this oxygen in real time. So in reality, it is not attached to this oxygen. Tetrathionate exists as an ion. Is that clear what I am saying? Or your question is different?
Yes.
Excuse me, sir.
Yes.
So do a lot of questions come regarding these states of how we draw this and all of this?
I didn't get your question. Repeat it.
So do we have to draw the structure in exams too? Is it asked to draw the structure for any of these and then explain something regarding?
Yes. The good thing is that you can't be asked question from anywhere. It will not be out of the word, from out of the word. It will be from your book. So you have very limited structures there which you have to memorize.
Okay, sir.
Now there is another reason also where you can have a fractional oxidation state. Two, I have told you that in rare cases O2 minus and O2 plus, indeed there will be fractional oxidation state, right? And that is an exception. So first reason, now first reason we have talked about, okay. Apart from exception, there are two reasons only. First reason we have talked about, that within an element, there are more than one oxidation state shown by one element. And there is another possibility. The possibility is that the compound itself can be a mixture of two compounds. So for example, if we have Fe3O4, okay, Fe3O4 is not just a single compound. It is actually a mixture of ferrous oxide and ferric oxide. When these two are combined, they exist in combined form. So it results in Fe3, 1Fe and 2Fe, and O4, 1O, 3O. Okay. So when they combine, they form Fe3O4. And the oxidation states of iron in both of these is different. You know, FeO is actually ferrous oxide. Here it is +2 oxidation state, and Fe2O3 it is +3. So their average, in this case again average, will be the overall oxidation state. But the underlying reason is different. Here again it is average, but the underlying reason is different. Here the oxygen is, iron is not in just one compound. It is actually in two different compounds. So these are very common examples: Fe3O4, Mn3O4, Pb3O4. The reason in case of Pb3O4 is, uh, in all three it is same, but the mixture compounds, okay, components, sorry, are different in Pb3O4, and in Fe3O4 and Mn3O4 these are, similar ones. No, sorry, in this one it is one, in these two it is similar one. So there is a question. So first I am doing a question to make you understand that why the mixture can lead to different type of reactions. Okay, due to mixture the reactions can be different. So the question is, why do the following reactions proceed differently? You have the same mixture compound here, say compound Pb3O4, Pb3O4, but when we get it reacted with HCl, which is an acid, we get PbCl2, Cl2 and H2O. But when the same compound is reacted with another acid, HNO3, this is again acid, we get PbNO3, PbO2, H2O. Why this difference is there? This is actually explained. This is because it is not just one compound. It is two different compounds. I will come back to the solution of this question. I'm just moving forward. Okay. First, I will explain that why the oxidation state of, say, lead or manganese or iron is different in these cases. So first I am considering Pb3O4. Pb3O4 is actually a mixture of PbO and PbO2. It is 2 parts PbO and 1 part PbO2. So that's why it is Pb3O4. 2 Pb, 1 Pb will make 3 Pb total. Okay. 2O and 2O will make 4O. But if you calculate the oxidation states here of lead, in this case it will show +2 oxidation state, because oxygen has -2, it will have +2, overall 0. In this case PbO2, it will be X plus 2 times -2 will be 0. There are 2 oxygens and one oxygen will have -2 oxidation state, means X equals to +4. So who will tell me the answer? What will be the overall oxidation state of lead in this case? Who will answer? What will be the overall oxidation state of lead? Okay, Arjun, tell me the answer.
Sir, is it 8 by 3?
Okay, tell me the reason.
Sir, like sir, the oxidation state of P like O is -2. So like the overall charge on any compound is 0. So like I found equation 3x plus 4 into -2 is equal to 0. So I got x as um, uh, I got x as like I
No, that is something you calculated from PB304. I'm asking the question that we have found the oxidation state as +2 and +4. So what will be the overall oxidation state then? You know, we have already done these type of questions that we calculated the individual oxidation states and then we got the average of that. Here also we will get the average. But before we get the average, this is 2 PBO, not just PBO. If it would have been PBO, then the average would have been just +2 +4 by 2. That is 3 +3. But it is actually one PBO, another PBO, and PBO2. It is a mixture of these three molecules. And here also it will be +2 oxidation state. Here we have calculated +4 oxidation state. It means average oxidation number of lead will be +2 +2 +4 divided by 3. That is +8 by 3. Is this clear what I am saying? These questions are very much common and you should be very crystal clear about it. If you are not sure what I am doing, let me know.
So for one PB oxidation state is 2. Since it's given 2 PBO, we multiply it by 2 and find the average. So like that.
We added all the oxidation states and divided by their number to get the average. Okay. Yes, you are correct.
Yes.
If you are talking about here that because we have two molecules of PBO, that's why we multiplied +2 by 2.
Yes, sir.
So the average oxidation state will be whatever molecules we have. In all those molecules, whatever is the oxidation state of the element we are talking about, add those oxidation states and divide by how many oxidation states are there. Simply average. Okay. Same is the case with Mn3O4 also. So Mn3O4 also exists as MnO, 2-MnO, and MnO2. So 2-MnO you can write MnO and MnO. In exam you don't need to write like this. This is sufficient. 2-MnO and MnO2. Here oxidation state of manganese is +2 because oxygen is -2, manganese +2, neutral. Here oxygen will have 2 into -2 -4. Okay, so oxidation state you will write -2 only because one oxygen has -2. This is something I have told you in the previous class also. Oxidation states, if you write it for a molecule, will always be for one atom. Okay, in balancing we will talk about that how we convert that to molecule. But if you're writing oxidation state, you will always write for one atom. Okay, but here it is X. So this -2 is 2 times. So that's why it will be +4. X plus 2 times -2 equals to 0. X equals to +4. So manganese will show oxidation state +4 and here +2. But here we have 2 manganese. So it will be +2 +2, 2 times +2. And then we will have the other one +4 divided by 3 +8 by 3. So similar one, PB304 and Mn3O4 similar. Very simple. Now Fe3O4 looks like that it is similar to PB304, but it is different. And the reason is that Fe3O4 is mixture of FeO and Fe2O3, not FeO and FeO2. In that case, that was PbO2, MnO2. Here it is Fe2O3 and just one molecule. So here -2 +2 oxidation state. But here oxidation state of iron will be, if it is X, for example, you will say 2 times X plus 3 times minus 2 equals to 0. Means 2x equals to plus 6, x equals to plus 3. So here it is plus 3. But again, how many irons are here? Here you have 2 irons. It means the average oxidation number will be plus 2 plus 2 times plus 3. Here you have 2 iron atoms in one molecule. So you will write plus 3 divided by 2. Again plus 8, sorry, divided by 3. Again plus 8 by 3. The oxidation state is same, but the calculation is different. And subtle questions can be asked from here with this difference, which you need to remember. Any confusion here? Any part?
Sir, why are we adding this 3 twice, sir? Because it is already Fe2. So, sir, we found the oxidation state for this compound in the reaction itself by putting 2x, sir. Then why again did we put it twice? This plus 3 value.
Because you have got the value of x, you have not got the value of 2x. You got the value of x as plus 3, but you actually have 2x here.